Scroll down here to the third one. Right. Number 3 says the tension caused by a wave moving along a string is found using the formula. Sorry, we'll be able to read it all. There you go. It's found using the formula T equals m times v squared over L. If m is the mass of the string in grams, L is the length of the string in centimeters, and v is the velocity of the wave in centimeters per second, what is the unit of the tension of the string T? They're asking for the unit, so they're not really worrying about the numbers part of this, okay? But they want to see, well, what unit is created over here, okay? And so we need to, or the way I like to do it is kind of like plug in the different pieces here. Your M, right, was the mass in grams, okay? So we have grams, and I'm just going to abbreviate and call that G. V was the velocity of the wave in centimeters per second, okay? Per. Okay? Per means to think about miles per hour. It's the number of miles you go per hour divided by the hours. Okay? So per is going to mean divide here. And so I'm going to represent that as cm for centimeters divided by s for seconds. I'm just going to use s for seconds here. But remember, it's squared. Okay? And so I'm going to square it. And it's all over L. What's L represent? The length in centimeters. So I get to use centimeters again here. Now, I don't really have the same thing as any of these answers at this point, right? This is pretty kind of ugly looking, so I'm going to try to kind of simplify this. I see a couple centimeters, some squaring, some things like that I can do. Squaring means you multiply by itself. So I'm going to take centimeters over seconds and multiply it times centimeters over seconds. Well, when you're squaring something, you square the top and the bottom individually. So that's going to give me G times centimeters squared over seconds squared, all over centimeters. So I've got a fraction here, and I need to multiply it times G. Now, one thing to remember here, when you're multiplying fractions, or by a fraction, it's easiest to have two fractions. So I'm going to create G, make that a G over 1, so I can multiply a fraction. When you multiply fractions, it's straight across, not cross multiplying here, right? I'm multiplying straight across. So G times centimeters squared. On top, and then underneath that it's 1 times centimeters squared, so that's just, or excuse me, not centimeters, seconds squared, so it's seconds squared, and then that's all over centimeters. Now, I have a fraction that's being divided, right, that's inside another fraction, so it's a fraction divided by another number, right, and I can actually make this other number a fraction, so it's a fraction divided by a fraction. Now, it may have been a while since you did this, but what we do when we have that is we're going to change it to a fraction multiplied by the reciprocal. Reciprocal means we flip it over. So I'm going to have grams times centimeters squared over seconds squared times, flip this over, the reciprocal, 1 over centimeters. Okay? You can multiply it out, or I can kind of see, especially with it just being a 1 here, I've got these centimeters. One's in the numerator and one's in the denominator. Okay? The exponent here is 1, up here it's 2. Okay? You kind of subtract those exponents to kind of cancel out here. So this is going to cancel out here, the 1 here. There was 2, but that 2 is going to become a 1, right? One of them was taken away underneath. So now I have grams times centimeters divided by seconds squared. There's not much else I can do. So now I'm going to start to kind of look at my answers here, right? I've got centimeters per second squared, centimeters per second squared, grams per centimeter second squared, right? So this kind of means times when they're together, and the per means divide, right? Well, what do I have in mind per second, right? Mine's on the bottom, per second squared. So that kind of eliminates a couple of these choices here. That eliminates C, and that eliminates D. And I notice in my first answer, right, it has grams, but the B does not, okay? I have grams still here. I have grams times the centimeters per second squared. Our best choice is A. And I know that's a long, maybe, explanation. Hopefully you can get to where you can kind of work through that a little bit quicker, and maybe you'll start to notice some of those things. But that's kind of how that one works. One way to do it. All right. Number 4. The kinetic energy of an object in motion is found using the formula Ke equals 1/2 mv squared, where m is the mass of the object in kilograms and v is the velocity of the object in meters per second. If the velocity of the object is 20 meters per second, what is the coefficient of m? Coefficient means what is m multiplied by, okay? And right now it's being multiplied by 1/2, but it's also being multiplied by velocity squared, okay? So those are the coefficients, and we can actually kind of put that together, right? Because the order you multiply things doesn't matter. So the coefficient is 1/2 v squared, right? That's what's being multiplied by m. Okay, and so I want to try to figure out what this is, and they told me in this part here that v, the velocity of the object, is 20. Okay, and so I'm going to plug 20 in for v, and I got 1/2 times 20 squared. Now it's a matter of kind of using my calculator here. 20, follow your order of operations. I want to square first, so 20 squared means 20 times 20 is 400. And then 1/2 times 400, that's half of 400, that's 200. And so our answer here is 200 meters squared second squared. All right. So that was a little bit maybe easier one, and we've got to remember what coefficient means. Okay. Going on to the next one. All right. A certain population of bacteria has a growth rate of 0.02 bacteria per hour. The formula for the growth rate of the bacteria's population is A equals P0 parentheses 2.71828 to the 0.02 t, where P0 is the original population and T is the time in hours. If you begin with 200 bacteria, approximately how many of the bacteria can you expect after 100 hours? All right, so this is one where they give us a formula and we have to kind of apply using it. Okay, and so a couple things. PO is the original population. Well, they tell me in this problem the original is you begin with 200, so that's going to go in for your PO, right? The other part of the formula is the time, right? T. It says T is the time in hours. Well, I know that I have 100 hours. That's my T. So I need to plug in here. So I'm going to have 200, 2.71828 to the 0.02 times plugging in 100 for T. So I just plugged in, and that's how I'm going to find my A. Now, part of this is a calculator, right? You can use a calculator, and you can probably type this all in at once in a calculator. Got to remember order of operations. A couple things, though. Parentheses, which there's nothing to do inside my parentheses, right? Then it becomes exponent. So I need to figure out what my exponent is. So 0.02 times 100, right, in my calculator is 2. So that means now I have 2.71828 squared, right? Not times 2, it's squared, okay? So I need to do my exponent. So I need to square it in the calculator. 2.71828 squared gives you 7.38904615. Now you don't necessarily have to carry it out that far, but we do want to, we see the decimal places carrying out here a little ways, so we don't want to shorten it too soon. And I need to multiply by 200, right? Now, notice something here. I don't need to clear out my calculator and retype this all in. That's in my calculator right now, so I'm just going to hit times 200, and I get 1477.809, right? 232. So I look at my answer here. C, right? We see that they've rounded that 0.809. They rounded to 0.81, but that's our best answer there, C. That's the amount of bacteria we can expect after 100 hours. So this was really a problem with using a formula, plugging in, being able to use a calculator. Might point out to you what type of function or formula is this. It's an exponential. Notice we have the exponent. So as time went on, it was going to grow faster and faster. Those bacteria there. All right, number 6. Two angles of a triangle measure 20 degrees and 50 degrees. What is the measure of the third angle? All right, you have a triangle. One thing to remember, your angles of a triangle, those 3 angles, are always going to add up to 180. Okay, so I know those 3 add up to 180. And so they tell me in the problem, well, one of them's 20 and one of them's 50. What's this one over here? Okay, well, I know again that those 3 have to add up to 180, so I kind of just use that. We're setting up an equation here. 20 plus 50, I'm going to call it x, should equal 180, right? Solve an equation, I want to get the x by itself. So I'm going to combine my like terms. First, I notice here 20 plus 50 is 70, plus x equals 180. I want to get the x by itself, so I want to get rid of the 70 over here. To get rid of the 70, it's positive, so I'm going to subtract 70 from both sides. X equals 110, right? 110 degrees, that's my C. Right, that's my C. Important part was to remember that the angles add up to 180, set up your equation, and solve. Hopefully we can knock that one out. All right. Number 7. What is the solution to the equation what is the solution to the equation P equals 2L plus 2W when solved for W? So we're solving for an equation. There's more than one variable. That doesn't matter, okay? Follow the same steps as any other time. We're just going to solve, okay? Solve means to get it by itself. Now, it's not 21. It's 2L, right? Because it's this is actually the formula for perimeter, right, of a rectangle. So we want to try to find the width, right? Get it by itself. I don't start next to the W, right? I start away from it. So I actually want to move this 2L first. And to move that 2L, I'm going to subtract 2L from both sides. It gives you P minus 2L equals 2W, right? Because these will cancel, right? 0. Then I want to get rid of the 2. It's 2 times W. The opposite of multiply, or the inverse of it, is to divide. So I divide by 2. Right? It cancels, and I got my W by itself. And I notice, right? There's maybe a little bit of simplifying. Sometimes they like to do or split it up, but my best answer is D over here, right? Or it matches up there. W equals P minus 2L divided by 2. Right? That would give you the width of a rectangle, given the perimeter and the length.